Okay, so now we're going to talk about incomplete and complete combustion. Okay, so complete combustion is when the oxygen and the reactant, whatever the thing is burning, they completely burn and there's enough oxygen for that combustion to take place. In an incomplete combustion, there's not enough oxygen. All right, and to demonstrate this, we can use the Bunsen burner. Right, so what I'm going to do is I'm going to quickly light the Bunsen burner, and again we're going to put it on just the normal safety flame that we normally use to start with. So open this guy up. All right, so there's our normal safety flame. Okay, so it's now got my glasses on. All right, so it's now got a lot of or very little oxygen going into it. Okay, so if I now open this up as we normally do, we notice that it's getting more oxygen is getting pulled in from the bottom of the thing and allowing for a much hotter flame to be produced. This, as it stands, would be a complete combustion. All right, you'll notice that there's no smoke, there's no soot or whatever, anything like it. It's just everything, there's enough oxygen for it to actually completely burn the propane in this case. But when I close this down, I end up with this safety flame, which we always use. Now, this is actually not a complete combustion, right? There's actually not enough oxygen to burn all of the butane or propane that is coming through this gas pipe. Right, to prove that, and this is why we don't ever use this, all right, is if I had to put a container here, all right, and using this flame to heat it, okay, well, what do you notice that's going to happen on the bottom? All right, you can actually see it's getting black on the bottom, okay, as this heats up, okay, you can see, there it is there, okay, so this blackness, this soot that is actually showing on the bottom of this container, all right, switches go off, there you go, you can see it there, it's sort of dark sooty color, all right, that is actually the carbon which is left over that is not completely burnt. All right, so you've had the oxygen coming in here, reacting with the propane, it's combusting, it's creating a normal combustion, right? And when we combust hydrocarbons, which is in this case, so carbon and hydrogen together to create butane or propane, all right? When they burn, they create a very simple equation, right? And so that would be the following. So if I said to you, so butane, well, let's just see. So we've got, so propane, let's do propane first, C3, H8 plus oxygen, right, is going to give me the carbon dioxide plus water, right? Carbon goes to there, the oxygen goes to there, right? And then we would have to balance this thing. So we end up with 4 there, which gives me that. We need a 3 here, okay, which gives me the number of carbons. And now my oxygens will be 6, and 4 will be 10, so this will have to be a 5 over here. Okay, so that would be the balanced equation of what we've just experienced. So when it's burning, full ball burning with enough oxygen, this is the thing that's being produced. So water vapor is being released and carbon dioxide is also being released. Okay. When we didn't have enough oxygen, right, you ended up with some of that carbon being deposited on the bottom of this thing in the form of soot in this case. And you can see it rubs off onto my finger there. You can actually see the actual soot that is actually formed on the bottom. Okay, so that is an incomplete combustion, and you've ended up with some of the carbon not going to carbon dioxide to form the oxide, carbon dioxide, all right, which we talked about in the previous video, but we've actually now talking about some of that carbon actually being deposited as carbon itself. That's why you get that black sooty thing on the bottom of the beaker. All right.